This is the first video I'm making to support some difficult concepts in GCSE maths. And the first concept we're going to be encountering is completing the square. So completing the square is going to be a 4-video series I'm going to be making. And for each part, it's going to be escalated a difficulty level. So we're going to be doing 8 questions, and each part has 2 questions. And we're going to be exploring all the concepts of completing the square just in these 8 questions. So hopefully, after the 4-video series, you'll be comfortable with completing the square. And hopefully you can get all the points you can get from completing the square in the GCSE test, which is in a few months' time. All right, let's start with the first question. So for the first question, instead of trying to directly solve it, I want to first talk about the mechanism of completing the square. So in classes, this is often, ignored, or the teacher only tells you once how to derive completing the square. But ultimately, completing the square is a very useful thing to do, and it's better to understand the underlying mechanisms of how it works. So yeah, let's start with that. So first of all, we need to know what the goal of completing the square is. The goal is already set over here. So this is the goal, right? We want to put a quadratic expression in terms of this form. So brackets x plus p squared plus q. All right, so, but what does that mean? How can we make sure that p and q yields this expression? So what we can do is, for x plus p squared plus q, we can expand this just in usual, arithmetic. So expanding this, we get x squared plus 2px plus p squared plus q. And this is equal to x squared plus 6x plus, minus 2. And if you look at this carefully, then you would notice that this x squared is associated with the x squared, this 2px is associated with 6x, and the p squared plus q is associated with minus 2. And basically what that means is we can associate coefficients together. 2p is equal to 6, and negative 2 is equal to p squared plus q. Okay, so what does that mean? That means we can write the coefficients together as the same thing. So 2p is equal to 6, and p squared plus q is equal to minus 2. All right, so this equation directly yields p equals to 3 if we divide 2 on both sides. And because p is equal to 3, this means that 3 squared plus q is equal to minus 2. 3 squared plus q is 9 plus q. So 9 plus q. All right, these are starting to get a bit tricky to differentiate. So I'm going to do q with a tail on top. So 9 plus q is equal to negative 2. So therefore, q is equal to negative 11. And yeah, we have got p and q. So p is equal to 3 and q is equal to 11. And you might be wondering, I know a lot of you don't use this method, but this is the mechanism of completing the square. So this is the rigorous method to do completing the square. Every step is outlined here. However, there are much easier methods you can use to do the completing the square. And this is the method you'll be most likely taught in class, which is to divide this number by 2 and then see what happens. All right, so x squared plus 6x minus 2, that's equal to x plus 3 squared. And we have to subtract a non-constant out front in order to subtract, x plus 3 squared. That's equal to x plus 6x plus 9. So what we want to do over here is we want to subtract that 9 to get rid of this 9. Right? So, oh no, I'm subtracting the wrong thing. Okay, so this part is this. And what we're missing here is a minus 2. So all we have over here is x plus 3 squared minus 11. Both of these methods are tantamount, so they're equivalent. And if you use these methods correctly, then you'll be able to get the right mark. And that's it. This is all you have to write to get the 2 marks. So let's look at the next question. So now we know the mechanism of completing the square, so how it's derived, and we can use the short method now. So, all right, this is the usual format, a quadratic expression. We want to express it in this term. Well, this is changed to a and b, but that doesn't really matter. I can write, alpha, beta. The variables don't matter. So if we write this in this form, then we can write, this. All right. So x squared plus 10x plus 3, that's equal to x plus 5, because 10 divided by 2 is equal to 5. We have to subtract 25 in order to get rid of the constant coefficient over here. This plus 3, so that's equal to x plus 5 squared minus 22, because 25 minus 25 plus 3 is equal to 22, minus 22, sorry. And this means that our answer is x plus 5 squared minus 22. So this is equivalent to this. I mean, we're done with the questions, but why do we want to do completing the square? So in the next videos, you'll be able to explore why we actually want to do completing the square, because one of the most important things in math is to understand why we came up with a concept, or else it's going to be really boring to, learn concepts without knowing why we want to do it. It seems really useless. So, yeah. Please anticipate the next videos. See you soon.